Hello everyone, my name is Ethan from Blender CN community, aka Cong009, and today I'm gonna talk about color correction, and I hope you can learn some tips from this tutorial. So first, let's go to let's get the uh, outline. So what is color correction? So what is color correction? Color correction can be used in both 3D, which is CG animation, but also can use for the real shot footage, like most recent the Blender the latest Blender open source movie Mango project is almost released, and they will shot some real person acting footage and combined with the Blender created creatures. It's a really cool movie. They are facing the color question, and if you check on their blog, you will see they have some discuss to consider the improvement of color correction in Blender because you see, maybe you can shot the footage in different days and in different lighting, but in the final production in your movie, you have to make your color almost the same. That would be the color balance. So that is needs some color correction work. But in previously Blender, there's some problem and issues need to be improved. So especially the color space and the color correction. So today I'm gonna tell you some uh, quick knowledge about color correction and how it works. So the second question is how to see the color difference. So how we can distinguish the color difference and see if we watch the movie in TV station or from a movie theater, the big screen, maybe we will see there are some difference in the pictures, and if you pay more attention, you will see some difference in different computer. Like if you have a Mac system and if my system is a Windows, and the screen will display different colors for even for the same pictures which you are using. So let me take some examples. I download some pictures from footage from the Mongo project, and these footage are shot by the Sony 15.6 camera, which is a really good camera, and that is how it looks. The team provide two different uh, format. One file is JPG and one file is XR. So let's open the Photoshop and drag these two pictures, these two files into a Photoshop, and to see if we can find any different. So this is uh, this is two different file format for the pictures, and for honestly, I didn't realize if there's any uh, difference between these two pictures, but there you can see this the picture looks quite dull. It's quite flat. There needs some improvement. Like for we should increase the saturation to make this people looks quite vivid. That is what the team need to do. And now for us, we should find more. We can find some difference between these two files. First, you can see for JPG file, the size is 1.82, the size of this file, but for the EXR, it is 15.6. So, to this almost the same pictures footage, where is extent size file? Are these information about? It we cannot see because your eyes and your brains will always cheating your feeling about the colors. Our people's humans' eyes can only realize 10,000, almost 10,000 colors. computers, we should not just record 10,000 colors for us to tweak or to get some more modification. We should record more details. So let's see if we take a look at the mode of this picture. This is a JPG file, and if we check the mode, we can see it's a 8-bit channels. Sorry, this is a Chinese interface, but you can see this number here. It's a 8-bit channel pictures. So most of our pictures in our computers, internet, are using this color space. It's small and the editing is very fast for us. But let's see the AXR file. We can see it's a 32-bit. What's the difference between 8 and 16 and 32-bit? It's not just the size. It's about the color information, which it's out our eyes capabilities. So let's first look at the colors, um, the color depth. Color depth describes how much colors can be stored in the our pictures. For most of this, we can see the 8-bit colors, which means we can have 256 colors in each channel. This is just fine for people to read the information about this color. See, this is 1 bit, that is just the two colors, black and white. And this is a 2-bit for colors. It's way much better than the first one. It has colors, right? So let's move on and to see the 4-bit and 8-bit. Well, you can see more details in these pictures and it looks really shiny and realistic. And now let's see how about the 24-bit? Well, about 24-bit, that we can have, oh my god, how much of this number? That is 16,777,216 colors. That is true color. At least from my screen, I cannot see the difference, but in fact, this color can be the most close to the reality. So that could say this will be much better, and we can use more information of the color to get more tweak. But most of our normal cameras cannot record so many uh, colors. Like if most of our cameras can only just can take pictures for like the JPG file, or some better camera can get you some raw files, IW. That would be much better. But let's take a look at the camera which the Mongo team is using. They are using the Sony 16.5. It's a really expensive camera and it can record almost 32-bit colors. That is amazing. But if you read some information from their Sony site, that is too complicated. You can, especially the color space and how they transfer the color from the reality to the hard disk. It's just, you don't need to know too much details about these things. We just need to know what's the difference between the uh, different format. So we can see from the first image, it's just the S-log raw file. The color is quite dull, and you can see most of the place are really gray. If we do some layer color correction, the color will look much better, and you see the labs and the guy's face. It gets some more yellow details. That would be fine. And if you see the file format, just the ACS, which is just the Mongo team is using, the color is just a grid. More details and the contrast, they just look so much like a big screen movies. And for your information, most of the family camera can only provide you such a dual or gray colors. But that's the reason why this camera is so expensive. It can provide you so much information and record in this file. But for most of us, we don't have so much money to offer these expensive cameras, so we cannot get such kind of great footage as the color source. But if we know the concept, we can do some correction to transfer some normal pictures into this, most close to these pictures. And next, we'll see how we can do that in Blender. So next we'll talk about the color correction tool in Blender. So there will be some few things maybe most people will not pay attention to. Let's put in the video editing and let's add footage. Let's just put some image, okay? And I choose Mango pictures. Well, it's a 4K footage, so it will be a bit of snow in my system. Wow, it's waiting so long. Okay, so this is the footage. We import that into our Blender. And where should we see the information of the color correction? See here in the tab panel, we can see there are some small icons which most of us may not pay attention to. So let's get a new video section and to click the first one. See. So this first so much waves. We call that as a waveform monitor, and that is really powerful tools in the video editing, and that's the first one. Then the next one, we put this, and that is the Vectorscope monitor. These two tools is really just fine for you to do the color correction and make the color balance in your footage. What's the difference between these tools and how we can use that? First, let's see the waveform monitor. And if we transfer this to the painting, okay. Oh my God, it's crashed. Sorry, let's just restart the Blender and choose maybe a smaller file. That would be better. Okay, so video editing, and let's add another file. Let's see, we put this footage here. Okay, so this is just the footage, and let's get the video information. So here is the waveform monitor, and most of you may see this monitor. This is a vintage monitor, and most of people know that because it's quite common in like most like some Photoshop software. But for the video editing, we should know how to use this monitor. So what is a waveform monitor? We can see the waveform monitor is kind of 3D histogram. It's just put this information in a 3D value, and the most amazing part is it can give us a visual representation of the luminance level of a video footage. Instead of using some multiple colored pixels to make up a recognized picture, as this window does, the waveform monitor displays the luminance values of the video image in white waveform. How we call that. And the one more cool thing, it can just it can not only show you the information about the color, it can give you the location details of where is this color coming from the pictures. So let's see. Compare to the left and the right. We can see from this picture, this part is the sun, and it produces really some bright lighting. And let's compare to the waveform monitor. And this part of the wave is just so much higher above this other wave because this part means this section in the picture is has contain so much white information. It's really over white, and we can see there are some red color lines, and from the above and from the top to the bottom, the wave is just above this line, which means it will be quite dangerous if you shoot this picture in sun screen like the TV, because that colors in the TV set will not show this like we can see the pure white or the pure dark. That is dangerous. So we have to correct these colors. And from this the right part, you can see these are the trees, and the color is quite dark. So from the waveform monitor, you can see these points gathered here down to the corner of this monitor, and it should use how much black information here. Maybe we will see, okay, this footage is just looks fine, but from the waveform monitor, this footage is not fine. We need to correct them. The best solution is first we can reduce, maybe some of part of this place can be over wide. That is some super wide, but we cannot put most of this white above this color line. And we should also increase the black color to give more details. So how do you do that? First thing you can do in the video editor, you can click the N key, or just you can put the mouse here and grab to the left side. You can get your property file panel, and from this place you can get the use color balance. See how it works? You will get the color balance, and this represents the shadow, the mask color, and the highlight color. What how to correct this color from this picture for this picture? See, what we want to do. We want to reduce that a little bit, so we just click this place and put the colors down a little bit. You can see the waveform monitor is changing. Well, now the waveform is above the read line, and how it looks. Let's just switch. Well, it will not be that bright, and we can see a little bit more details from the cloud. That is how we correct that. And if we want to put this part of this color to a little bit less dark, we can click here to put down here, you know, just reduce that. See, we can get some more details, not that too much. We don't really need to um, stick to this line. We just do that and to make the picture quite balanced, not too black, not too bright. So that's how we do that. And there's almost no rules to correct the colors in Blender, but the most important rule is it should fit your style. Some style, maybe I can give some, this is a sunset sense. Maybe we can get more red colors for the environment. So we can give some more red colors here. And we can give some more blue colors to sky. So give some blue colors. That's how it looks. And maybe that will be a cool style for your videos. And if we click the N key in the waveform monitor, and here we can get the separate colors. So in the separate colors, this is the red color information location, and this is the green and blue. Well, almost we cannot see so much blue information from here, but they exist here. Maybe your monitors and the operation system will give some different colors, and you're working together with some people using uh, like some Mac system and some other monitors. And the waveform monitor could be the best solution to make sure all your guys' work can be combined together in the same style. That is how we do that. And this is a waveform monitor. And one more monitor is this, is the Vectorscope. So what is Vectorscope monitor? The waveform monitor displays the luminance of brightness of our videos from the black to white, and the Vectorscope it will use a circle graphic, not unlike a color wave. You know, it's not a color wave. This is a color wave. This is unlike a color wave to show the colors, hues, and the color saturation for the footage. From the center of this picture, of this Vectorscope that presents the color, there's nothing there. There's no color, and it should be black. If this wave reaches the side of this, the critical, and it will means your yellow color in your picture is 100% saturation, which sometimes is not that good. We should keep that in the middle of our footage. And sometimes, if we want to make the picture less yellow, what we can do? We can give more blue colors to, move this wave from left to right. How we can do that? We can just click here. You can see I'm putting more blue colors here, and the color is moving from left to right. And let's see how it looks in our footage. Now it looks really, really interesting. The sky shoots some nature color that is blue, and the sunset and the the mountain far away from the sun shoots the red color. Well, that and some, the lens flare. I think that is some lens flare shoots some nature color. Now this footage is finally ready to use. That is how we correct the colors in the video collecting. Let's compare how it looks from before and after. Well, the result will almost depends on how you designed for your videos. I highly recommend you to walk through check this website. That is Ken Stone's Final Cut Pro. He gives some more detail of the information about the waveform monitors and the Vectorscope. See, this is how it looks like in the Final Cut Pro, but I don't have any chance to touch this application, so I only have Blender, but the concept are almost the same. So we can use this knowledge to do the same job in Blender. See, this is this is the real Vectorscope. It should looks like. The Vectorscope contain two colors, the primary colors that is red, blue, and green, and the secondary color, the magenta here, and the cyan and yellow. That is how this Vectorscope exists. That's how it looks like. But in Blender, is that the only part we can do the color correction? I may say no. This is not just the only way. There's one more way to do that. Let's just first, save this Blender. I don't want to get it crash again. So let's come back to the compositing. And let's click the use node, and wait. I don't need the render layers. Anyway, you can, I will just input an image here, and let's see. Let's just put the Mongo pictures. Well, you can correct the colors for your the direct render output from your Blender, or you can do this for your real shot footage. I recommend you to do that for both, because in that case your footage and your, the 3D render result will compare almost, they all will look almost in the color space. That would be better. Great. So let's just get a scale. I don't need that. Let's put it as a render size, and let's see how it will look like. Click render. No, I think we should disable the sequence. Okay, now we can see the final result of this picture. So where we can get the waveform monitor and the Vectorscope, just remember to switch to the UV image editor and click T. See, here is what you can use for color correction, and they are just great. Let's make it bigger. Okay, now you can see, use Control and your middle mouse button to resize this, the uh, monitor, pick monitors. So now we can see how it looks like. So first one is a histogram. That is most of us can do, and we know how to use it, and it's almost quite normal. But we don't want that to help you to do the color correction. I will show you the waveform monitor here. Let's put a little bit more. That is the normal information for this, this footage, and this is a Vectorscope, and we will just disable the sample noise. And here the scope samples, if we click the full samples, that means it will get more details and more wave. You can see if I click this, it will give more um, a waveform dot in your monitor, give more details. But yeah, we can do that. We can click a full samples. Otherwise, you can, just 13% or 15% can make you work faster and the reaction really much better for big sense. And if you got more nodes, if you get a more node map, a big node map in your compositor, you will maybe reduce sample numbers to maybe 30%. But here we have we just have a texture, so a picture. So yeah, full sample. Now we can see the waveform monitor. We use the right click of your mouse to see the whole size of this monitor. And from the left side, you can see some numbers. That is from 0. Let's put that to 0, and you can see now it's really clear. From 0, 20, 40, 60, 80, and 100. That's some numbers, but you don't need to know too much about this number. But you have to know your colors should not the bright color should not above 100, and because 100 will present the 100% white. That is a pure white. And the 0 will present the pure black. That is not really good because the pure color will lose some details. We don't want we don't want to lose details. So here, this is the EXR file. We can see there are lots of information out of the 100 levels. And next, let's just duplicate a image node and import the JPG file and connect it to here. Let's see what's different. See, this will just cut off. Now you know what is the difference between these two formats. That is the difference. The EXR file can record more information. These colors is out of our eye scope, but they can be really useful for our Blender, like some editing tools, to uh, tweak tweak the colors. But if we use the JPG, we don't have too much options. If we want to reduce the bright side of the color, about this wave, it will be nothing there. So that means we will lose details. But if we're using the EXR file, see, even we just reduce the wave from the outside to downstairs, and we can still keep the details. That is how it looks like. It's really great. So I may recommend you if you want to make your short movies, please try to record the movies of your footage using some files like the EXR or RAW file format. That will be really enough and great for you to, get the uh, color correction, make it work better. And let's see how this Vectorscope looks like. Vectorscope just shows a similar to the Final Cut, and that is how it looks like in Final Cut. Here, there will be some markers and some letters, like this place will represent the red, yellow, and green, some things like that. We can recognize the colors, but here in Blender, we don't have that. We just it's a cube here. Maybe there could be some improvement in future release, and meanwhile, this is there will be some difference between the Vectorscope and the color wave. Let's see what's the difference. Let's add the color balance. So here, let's see for the Vectorscope, the red part is from the top side, maybe the 11 o'clock, and the 3 o'clock is the blue, and the 7 o'clock is the green. But compared in the color wave, the red color is in 6 o'clock. That is just in another side. But so this will not give us some comfortable ways to correct the color, but maybe there could be some uh, change or enhancement to get some improvement for this color. But here we just need to know what's the difference and remember that don't make mistake and that will be fine. So here is the red, green, and blue. So how it looks like, we can see from this picture, this footage, it looks like we have so much green colors in the footage, right? That's our eyes can tell you. But from this footage, we see this wave should there are lots of the high saturation of red color. Where is this color? So with the help of the Vectorscope monitor, we can easily find where is these colors, and we can avoid such things happen. So let's guess. Let's put this to the side, and we get some matte color, some crop node. Okay, and let's put 100 to 500. And let's put that to 102. See, it looks like I just try a shot. In this part, I crop this part of the image and it looks like the read information will be next to this place. So let's put that a little bit higher. Well, yes, I think I make right luck. So this read color information should be located here. And where we can find that, let's just keep moving and put that to 3100. Well, that looks good. Okay, and it's more and more close. Oh, see, this is where these colors coming from. That is colors from the lab, and it will produce some oversaturation in colors for the image. That would make some, give this Vectorscope pretty not that. If this is not a lab or some more, people's face, that would be not good because if this kind of wave details exist, we cannot see the face. Also, we can also see we can also locate the colors from the waveform monitor because you can see here the wave is just shoot pretty high here. Let's just mute this node and see. That's how we can find. That's how we can find the oversaturation color in our pictures. So what we can do, first, of course, we can, reduce the saturation by the uh, color balance node. But here, for this scope, I don't think this needs some correction. And for this footage, it looks fine. So we'll just keep that. But for some footage which like if you shoot that footage without color correction in your camera and some color will become it should be mm, white but it should yellow things like that. Let me just show you some bad shooting footage and to see how we can correct that. So this is example and that is not a good shot. You can see for this lamp because there's no correction, mm, color correction before we shoot this footage. So it shoots some yellow colors for this lamp and the wall. But suppose this should be white. What we can do? We should fix this. So that means color correction. How to do that? Just get the color balance input here and we let's first see the waveform monitor and we see the colors locate from the yellow part. It's too much. So how we can do correct that? We should move this waveform to the negative side. That means the blue colors. So let's just add some blue colors, especially the highlight of the colors. And you see the yellow it just become less yellow. And let's check the waveform monitor and we want the um, white side to be a little bit more. At least it's a lab. We don't need some more details from the lab, so just keep that. Don't cross the 100 level. That would be too much. Just control that. And the dark side. Oh, sorry. Okay, so that is too much. And coming to the dark side, we can increase that to put that above the red line. That's a little bit too much. Okay, so it's almost fine. And we check some here, give more color information from the for the the blue side. Sometimes you just try and try to get some the best uh, correction colors. Now it looks much better than before. We mute that and compare. You see this color will become much more natural than before because without the correction, the color should an unnatural yellow. We just make it looks what it should be like. That is some similar white here. So that's how we correct this. And coming to the EXR file, which we just said, there's some detailed information. It's out of our just mute this one. It's out of our eyes accept capability. So how we can make it visible in our sense? So here, let's just input one more image and we'll see how to do that. Let me find some best. Okay, so this is a table, just a pretty normal sense table. And we can see from the wave monitor, it gets some more in color information from over 100 just 9. So, but just from here, we cannot quite realize where is that details. So we should make it visible. And also, you can see there are too much saturation in the Vectorscope. That is too much. Okay, and the color is coming to the yellow. That is how we can correct that. So let's see how we can make the color visible. Let's just add a tone map. Where is a tone map? Put it here. Wow, that's too much. Change this to RH, simple. And you see there's some difference. If something is working in this two monitor. Okay, and let's see change this gamma because there are some difference between the different monitors. And gamma sometimes is the best tool for you to correct colors, to change this color into different color space. And for this side, we can just um, uncorrect the color because this pictures is recorded in the non-linear color space, but in our computer system in the Blender, it's a linear system. It's a linear color space, so we can just invert the gamma file value to get more details. And why we choose 2.2? Because this value may depends on which system you are using and which monitors you're using. But coming to the Windows, and you can try 2.2, and that will give you more details. And you can see here, well, we see the kind of saturation. It did looks much higher, but see here the waveform from the waveform monitor. The colors just shoot the details, and it will be um, controlled between the 0 to 100. Let's compare that. See, the color just shoot up, and how it looks like here. Well, it may be not the best correction final result, but with these powerful tools and with some sufficient color information color resource, you can get some more tweaking. Otherwise, if you record this picture in JPG file format, it will be not that easy to get these details information from the dark side. But with these powerful tools, even you don't have any chance to get these um, quite sufficient color information footage, you can still try some of these um, node and with the help from these few monitors to get some similar result. And these two monitors is really powerful. So I hope you guys can learn something and get some ideas about these two panels. I hope that could be useful for you. Well, by the end, um, my name is Zhongzhong009 and my email is here if you have any questions. And I hope you can send me an emails and I hope you will enjoy this tutorial. Okay, so much for this. Bye.